Okay, hello all you crazy people out there. My name is Michael. I like wizards and dragons and making games, and welcome back to making tower defense games in Game Maker Studio 2.3.2. Alright, that intro is getting longer and longer. So on the subject of 2.3.2, if I can find the project here, Bombardier. There's been an update. 2.3.2 is a beta update, and I'm going to take an interest in one particular thing in that update before I move on to the things that I was planning to do in this video. And that's going to be, first I'm going to run the game just to make sure that everything works. Once that happens, I'll just like mark a commit without actually changing anything, just with the updated version number and stuff. We shall see how this goes before we get ahead of ourselves. There's always the possibility, it's probably not going to like break anything when I update Game Maker today. But there's always the possibility that things go wrong in ways that you don't expect them to. I can't build that right now because I don't have enough money. Let's see. I can build that though. Alright, send you in. But it looks like everything's working. There's no funny visual issues. There's no like mysterious crashes or anything like that. This works the way it did before. There is one particular thing I'm going to take an interest in, and after I do this thing, that is going to be the 9 slice. The 9 slice is a new feature in Game Maker Studio 2.3.2, currently in beta. Soon enough, it will be in the regular version of Game Maker, which means that whatever 9 slice code I had before, what was it? Okay, I called it here rectangle 9s for 9 slice, as in like I can't be bothered to type out the full word. This we don't need anymore. This is the old 9 slice code. We can use the new 9 slice code. All of the UI elements that were on over here. One, we can make them look better because we don't need the like funny room editor shenanigans anymore because 9 slices are now just built into Game Maker. First, I will, I guess, do this. This is SPR 9 slice, SPR block raycast, and SPR text label. Let's turn on the 9 slice settings for you. That can be that. Drag the boundaries of the slices just into the middle. And now, I don't know why that panel is so big. Now we can stretch out and slice the sprite however we want, and it'll just be automatic, and we don't have to do anything funny, which is always nice. I can also actually cut this box down a little bit. I don't remember exactly why it was so big. I think that was just so that it wasn't like a couple pixels off around the sides, but honestly that doesn't bother me that much, so I'm okay with leaving it. There's also these, which is what most of the buttons in the game are using. Okay, so this is now fine, and we can see that in the room editor the changes are reflected. This is something I did not mention in the video in which I talked about 9 slices, but it is a valid point. You can also use the 9 slices just in the room editor, and they will be displayed correctly, however you need them to be. If I were to turn on this, the tower select UI, you'd see that they all do the right thing as well. Lastly, SPR text label. This isn't anything exciting, but I will slice it anyway, just so that it's there, because it feels right to have it there like that. Now, drawing these, if I were to run the game, I believe this would complain at me because I can't use draw sprite general with sprites that are 9 slice, that have their 9 slice setting turned on, as you can see. So I'm just going to have to update a couple parts of code. I can get rid of draw rectangle 9s entirely. I'm not going to need that anymore. The parts in the code where it's referenced, instead of saying sprite index sum image x, y, width, height, I can just draw sprite stretched, or use several of the other drawing functions and use the same arguments. That's the one that was deleted, so it's not going to show up. I can change that here as well in UI text, and UI block raycast is going to do the same thing. And now I should be able to just run the game. And everything will be back to normal. How long did that take? That took about 5 minutes. Okay, is everything back to normal? Everything is back to normal. Wonderful. If I select you, the tower UI is correct. Okay. Actually, wait. The tower UI also has a little bit of overflow on the sides, because I don't remember why I did that. I think it looks dumb now. Anyway, now it works. New 9 slice code. That's great. The other additions to 2.3.2 in the beta, I don't really feel like messing with right now. I don't really feel a great need to mess with any of that. What are the things we even added? There are some like changes to audio groups and stuff in the way that they were cached, so that when you build the game, it goes a little faster. I don't have any audio in this game yet, and besides, that's something that's hopefully at least invisible to me, and just has to do with the way the game maker builds the game when you hit F5. Anyway, so the main subject for today, now that that's been taken care of, is going to be a special tower type. The last special tower type that I wanted to add to the game. Someone a long time ago in the comments suggested a magnifying glass, because when you like hold a magnifying glass up to the sun in a certain way, it concentrates the light at the focus of the parabola, and any insect-like thing that tries to walk underneath will not have a good time. That's a little bit ethically questionable, but for gameplay purposes, it should immediately be recognizable in what it does and how it behaves and what kind of gameplay it uses. Was there a button for these things yet? What are you? Variables, flypaper dispenser. Okay, so I'm going to create another button. Drag the UI down a little bit, a little more than that, thank you. Your variable is going to say magnifying glass. Your creation code is going to involve creating another tower. Okay, so this does not exist yet. I have to actually implement this. First thing is going to be, I need an existing tower to copy and paste. Let's just go with the basic tower to copy and paste, because it'll be very similar. It's just going to be drawn somewhat differently. Copy and paste. A lot of this junk can go. I won't need this for very much longer. Entity tower. I'm just going to call it glass so that I don't have to spell magnify every time. A lot of this is going to be inherited. Level, shot cooldown, or whatever. Shot cooldown is going to be somewhat irrelevant. Base fire rate, base range, base damage, base model, base bullet data. The modifiers, reposition method we don't need. The set stat mod methods, calculate stat methods. Level up, maybe re-implemented later, but probably not for now. Add to map, update. Update is going to have some things of interest in it. Shoot. We'll probably have some things of interest in it as well. Get target is fine. I can just inherit this. Targeting is going to work the same way for this thing as it does for all the other towers. Render. There's probably going to be something in there later. Cell can be inherited. Remove collision can be inherited. Okay, so the only thing really of interest for the magnifying glass is update, shoot, and render. Okay. Going to set you to tower glass, and where is everything declared, or where is everything initialized? Where's all this stuff initialized? That would be here. Oh, cool! I already have a magnifying glass like template that I can use. Okay, so it's got some basic parameters. It takes a tower model, and Here. We can create one there. This and everything else is going to work exactly the same as before. The on click when you click on the button, it's going to attempt to spawn a tower. It's going to have the text on the button, as you would expect. So let's run the game. And we've only added a little bit of new code, and it's not actually going to do anything really interesting. In fact, will it do anything at all since I kind of nuked the update method? Yeah, it's not actually doing anything at all since I nuked the update method. That's fine. Added space for magnifying glass tower. The room editor I'm done with. I can close that for now just so that it's not sitting there in the way. And the first thing that I want to do is make a tower model for this. I want to at least see that it's there, and I don't want to be looking at like dumb programmer art for too long. So I have Model Creator open. Let me take a quick minute and make something in the general shape of a magnifying glass. I meant to do this last night, and then I forgot to do this last night, so it didn't happen. Let's see if I can get something looking more or less the way I want it to in a short amount of time. Okay, so now here we have a magnifying glass. It is shaped like a magnifying glass. It is actually closer to actually being shaped like a magnifying glass than most things that I have designed for this game so far. That's okay. Let me close out of that. Get rid of Model Creator for the time being. That is saved as tower-glass.d3d in the game files. And if I just tell the magnifying glass tower data to load that in as its model, we can see it. I think it should be about the right size. There we go. That's not bad. Next, it doesn't do anything. This is just the shape of the model. I would like for whenever one of these bugs walks within range for it to rotate to face it. Let's see. First, added the magnifying glass. I'm actually going to, I think... I'm actually going to rotate the model itself first. We can do that by rotating you 90 degrees around Z. No? Alright, so it should have been the other way around, the Z axis. That's fine. So to start out with, it's going to point to the right, positive X. That is going to be the default position, 0 degrees rotation. Can I collapse some of these to make it less on the screen? Bullet bird, that makes sense. Bullet fly paper, towers. In the update, it's going to grab like the position of the nearest foe, or the it's going to say just, all right, target foe equals get target, whatever. That's just the standard fare for tower update. And we're gonna say instead of shooting it, at least for now, instead of shooting it, what is it? Rotation. Rotation dot z is going to equal point direction my x my y, and then the targets x and y. And that is going to cause us to rotate to face the target just automatically, at least I hope. If it doesn't, then I'm going to be sitting here for the next 15 minutes debugging it, if not more. Let's just plop you down there. I do wish to know, and you are not targeting anything, I do wish to know why the transparency in the middle of the glass is only showing there in the... It's only being drawn when you're like hovering over it and you see the glow. That feels like a problem that I should solve later, eventually. But the problem that it feels like I should solve now is probably more like, why is it not targeting? Because this is very much the... Yeah, it's taking the rotation into account too. This is very much the thing that we're dealing with right now. Let's send you in. And you are not targeting anything. What's your range? Is nothing within your range? The range is 1.5 tiles, which is actually pretty small. Alright, let's bump that up to 2.5. It's rather likely that nothing was actually within the range. 32 pixels times 32 pixel units times 1.5 is like 48, and I want to say that's about the radius of the base. 2.5 times 32 would be what, 80 instead, which would be a little bit more space. All right, there we go. So this thing is locking on. This thing is locking onto the things as it walks past. That's pretty cool. I really want to know why this is going to be a shader issue, but I really want to know why the blue transparency stuff is not being shown. All right. If I really wanted to get into the graphical aspects of this and like deferred rendering stuff, I could make the glass in the middle actually sort of like warp what you see through it, but I don't think I want to get that deep into it. That would be fun, but I don't want to sit here for 3 hours on video changing the entire rendering system to deferred renderer. Okay. Let's see. First, I can get rid of the show debug message. We don't actually need that. That's just there to make sure it works. Magnifying glass locks onto target. Then there's going to be the matter of attacking them, and I don't want this thing to shoot bullets. Unlike all the other towers, even even with the sort of generous definition of shooting bullets that some towers like Bird Nest has, I don't want this thing to shoot bullets. I instead want it to actually directly damage them. That would be something like your fire rate is 0 for 1. How many damage per second are you doing? Is that 1 damage per second? Let's say this is going to be 1 DPS, and that is going to be the value of base damage. Am I correct? Okay, so axe damage is like actual damage. That's the number of damage that we're going to be doing per second instead of per shot. And it's going to be continuous. Let's see, what do bullets do when they hit? We can just borrow the bullet code when they hit. On hit. Okay, so forward dot damage with the damage value of each bullet. That's the half of it. That's the part that we care about. If we wanted to, we could say bullet data to on hit. But we're not going to be doing anything with that. We're going to be bypassing that entirely. Target faux dot. Damage self dot act damage times dt for delta time. Let's see. This should cause them to take damage. Okay. And then, assuming this works, this is all the functional parts of the magnifying glass that I'm going to want. But there's going to be one more visual aspect to it, and that is, hopefully you are out of range. Which is not hopefully at all, actually. Okay, so that radius is actually still really small. One general thing that I need to do is, in some way, draw a ring around each of the towers so that you can see exactly what they should be able to damage. Like what's in the radius. But specifically, I want an indication that this thing is actually hurting these things. So you're going to loop around, and then you've taken some amount of damage already, and you should be, you may... Okay, no. If you were taking damage, which I think you were, it wouldn't have been enough to actually amount to anything. So let's bump the DPS up to 4. And then we can worry about balance later. I like the idea of a continuous damage tower. It's easy to make them overpowered if they don't have anything resembling a shot cooldown. There you go, now you're damaging them. It's easy to make towers like this overpowered if they don't have anything resembling a shot cooldown, but it's a little bit different. It's kind of fun in a lot of ways, and we can see indeed. We are just picking everything off. Can I send in everything at once? Are you just going to be able to, like, completely eat every wave that passes through? If I build another one? Alright. Death by fire. Wow. Alright, these 4 DPS is definitely a bit much. Either that or I'm going to have to bump up the cost, or incur some other penalty or both. Yeah, okay. That's fun. That looks like a game. Let's put that down to 2. And again, balance it later. That should be a good ballpark estimate. Magnifying glasses, damage foes. As I was saying, I want some visual indication that this is actually doing anything. And to do that, I'm going to create, I think, another model. And the other model is going to be in the same general shape as the magnifying glass, but there's going to be one, shall we say, crucial difference. Give me a moment. And that is going to be how it's drawn. So I'm going to use some special shaders to mess with the position of this little light beam that's sort of sagging out of the magnifying glass in a really weird way. This is not what it's going to look like in the game. We're going to be using the Vertex Shader to do some exciting things. First, let me just paint this yellow. A nice light yellow. Because sunlight is generally the color of yellow, at least it's depicted that way in media. I'm also going to use the alpha channel on the vertex color, and we're not actually going to use that for vertex alpha. We are just going to well, I guess we can. We are going to use the alpha for this vertex color for some other reason. So let me save this as tower glass beam.d3d, and let me show you how this is going to work. So in the shader, the focus point of the magnifying glass, this is not at all scientific, by the way. Don't use this for your science homework on how parabolic mirrors work or anything. We are going to just drag around the focal point to the exact location of whatever the tower is targeting, based on it'll take the rotation for the top part where the top part of the beam is, and then the focal point down here will just be dragged around and positioned in the room wherever. Again, parabolic mirrors, parabolic lenses definitely do not work like this in real life, but for gameplay purposes, it will do. So, let's see. For one, this would actually be a very useless object in real life. It would only work on enemies that are an exact radius away from the middle of the lens, because you can't change the focal point of the lens without stretching it or deforming it like a camera lens. Fun. Tower glass. I'm going to need a separate object. So there's some separate special objects. Glass beam. Magnifying glass beam, just in case I forget what it's called. And we are going to load in whatever I just called it because I've already forgotten. That is tower glass beam.d3d. It's going to be loaded in using the vertex format. The vertex format is going to just be the same old position, normal color, texture vertex format that we've been using. It doesn't matter that we're actually going to use this stuff in that vertex format for different things. The vertex buffer is the actual vertex buffer that's going to be coming out of that. And in the render, we can first just sort of cheat by, in the same place as vertex submitting, we can also vertex submit the game.magnifying glass beam, and it doesn't need to take the vbuff argument there because it's just a vertex buffer as is. Now break the game, and let's see, let's just plop one of you down. Okay. Oh, you're only doing that if am I drawing that in the wrong place? This is well, it's the shader. It's the shader that's messing with transparency in a dumb way. Okay, well, it's drawing it anyway. Let me run the game again, and you will be able to see it rotating, sort of. Obviously, it won't actually be focused on anything that we want. Magnifying glass. I'm just going to keep mousing over that, and you're going to see that it's going to rotate. Cool. Doesn't it all look like what we want it to? But, you know what? We can make do with that. So to actually make this do the thing that we want, I'm going to write another shader, and this is going to be graphical stuff. Shaders, magnifying glass beam, and we can set that. Shader set. No uniforms or anything that we have to worry about, but we are going to always have to. Sorry, we are going to always have to reset the shader when we're done. This is not the most efficient way to do shaders in 3D and Game Maker, but optimization is a subject for another day. This is just going to be a default pass-through shader. I'm going to re-enable the normal. It's not going to have lighting on it or anything. It's not going to have any special effects, but it should just be there now without messing with the alpha. Just throw you down. There you are. Now you're always appearing. And you're always unlit and some other stuff. Okay, so the vertex color and the position in space. One thing I'm going to need is I'm going to need the target foe. I'm going to say self.target foe is going to equal undefined. Instead of making that a local variable, I'm going to make it an instance variable for this tower struct. And that is going to mean this can be saved and used elsewhere. Let's see. Oh, I also don't need shoot anymore, do I? Because we're not actually using that. This tower isn't shooting things so much as just automatically like roasting them. And we can now access target foe here. Anywhere else, and we could give this the shader a uniform, and that's going to be a uniform vec3 target position. And let me just clean some of this stuff up because it bothers me immensely to have redundant stuff in my shaders, such as almost all of that. Same thing in the fragment shader. We're not going to touch the fragment shader. Okay. The shader's been cleaned up. So we have uniform vec3 target position. Let's go and pass that in to the... Let's go and pass that into the shader after we shader set uniform f. That is going to be shader get uniform. Wrong thing on my clipboard. The shader name, target position, and the values are going to be target foe dot position dot x, target foe dot position dot y, target foe dot position dot z. So this may be undefined. I'll deal with that specific case later. Target foe may now be undefined. I'm just going to wrap this in an if statement. If target foe is not equal to undefined, then we'll set the shader. Otherwise, we won't set the shader uniform. If you don't set a shader uniform after setting the shader, it'll just default to 0, all the values. Or if it's a sampler, it'll just default to the like default sampler, which is just a 1x1 white pixel. And this is going to influence the final position of the light. So we're going to start with the world position. I'm going to say vec for world position is going to equal gm underscore matrices matrix world. I always misspell the word matrix when I'm typing it in capital letters. Multiplied by object space position. We can then somewhat indirectly multiply the... Okay, so it's not going to let me do that. Directly. We can then multiply the world position by the view and projection matrices in turn. This should work. I should have those in the right order. I don't remember exactly off the top of my head what order the matrices need to be multiplied in and what the like the order of operations is, but that is actually going to not work. Okay, so let me figure out what order this has to be done in. Okay, there we go. This is this is doing the exact same thing as before, but we're just going the longer way around multiplying the matrices. So multiplication when it comes to matrices is not like commutative the way it is with just numbers with scalar values. If you were to multiply like numbers 5 times 7 times 3 together, it wouldn't matter what order you did them in. You would always have, what, 75? 5 times 3 is 15 times 7 is 105. It doesn't matter if you multiply like 3 times 7 times 5 or 7 times 5 times 3 or anything like that. You'd still get the same answer at the end. Matrices are not like that. If you multiply matrices together in different orders, you will get different answers. So I'm just going to multiply by the view matrix first to put the coordinate in camera position in camera space, and then multiply the result of that by the projection matrix to put it in screen space. Matrix math is fun. So what we're gonna do in the middle is interrupt. What we're gonna do in the middle is interrupt the world space position based on the vertex alpha. So we have in color. In color has a red, green, blue, and alpha channel. We are interested in the alpha channel. The alpha channel, as with all the other color channels, can be a value between 0 and 1. 0 is going to be no alpha. 0 is what the alpha of the focus point of the light beam currently is. And 1 is the alpha value of like the rest of the light beam that's just sitting there that shouldn't be moved around. We can use our good old friend linear interpolation, the lerp function. Shader languages do not actually call it the lerp function. They call it instead mix, which is just basically the same thing, except it can work on a scalar value, just any float, or it can work on a vector of any size. Can it work on matrices too? I don't remember if it works on matrices. I don't think it works on matrices. Anyway, the values that we are going to be lerping, boy, is that a fun word to say, is going to be the target position, which is going to be the starting value if the interpolation fraction is 0. We're going to have world position .xyz, because we're working with a vector 3 here, as the ending position if the interpolation value is 1. And the interpolation value itself is going to be in underscore color .alpha. This is going to return a vector 3. If the first two arguments were vector 2s instead, it would return a vector 2. If instead they were just vector 1s, also known as scalar products, also known as floats, it would return a float. So this function is overloaded to work with a vector of any size. We can just save this to a variable. We can call it vec4 updated world position is going to be a vector 4 of this position on the first three components of the vector on the x, y, z, and the homogeneous coordinate is just going to be the original w that we had before. And this should it's only a couple lines of code, but this should cause the light beam to automatically move towards whatever. That's probably a little bit too far away, isn't it? Alright, well, I can just wait for them to swing around, or I can rerun the game, which is probably going to be faster. I need to, I really do need to pay attention to where I'm placing these things down. So we're going to spawn things in. And now, that is actually not doing it. Oh, yeah. Wow. I didn't actually use this. Alright, whenever your shader is not doing what you expect it to, always start with like the dumbest possible fix, because that's often what it is. Or just game dev in general. You'd think after a certain amount of time writing code, there would be some errors that I just don't make, such as forgetting to actually use a value, and that's not the case. Okay, so it is indeed doing this. There's a little bit of visual weirdness with like a seam in the middle of the cone. I'm not sure why. Anyway, I'll look at the model to see if like I mess with a value in the wrong way later. But it's working, which is what I want. And I think I can commit that change. Mag. This is why I don't like having to spell it out more than I have to. Let me just look real quick at the model to see if there's a color somewhere that's like not what it should be. Okay, so this was actually just the culling direction not being set properly. Apparently, and I did not actually realize I did this, but I never turned backface culling on in this game. I don't know if I did that on purpose because I wanted to like talk about backface culling optimizations later, or if I just forgot. But anyway, the visual weirdness on the beam is no longer there. We've got a couple depth issues when it comes to the transparency in this thing. And I think my preferred way of dealing with that is just going to be like drawing the beam after everything else has been drawn to avoid those issues. We'll decide that in a minute. But there's one other thing, and we may notice that actually, unlike what I said before, if you don't set the uniform, where is it? If you don't set the shader uniform right after setting the shader, it doesn't initialize to 0, it just initializes to whatever value it already had. I could have sworn that they initialized to 0, but I guess that is not the case. That's fine, we can close that. If you're wondering specifically where I turned on and off culling, at the beginning of the 3D render, after the ground has been drawn, because the ground is just a plane which would otherwise be upside down if culling was turned on. We set the cull mode to counterclockwise, and then down here at the bottom, after everything in 3D has been drawn, we turn it off again because that would otherwise mess with the UI. Actually, you know what? Would it? The culling direction is of everything, including UI elements, would be counterclockwise. The winding direction. Okay, so that actually means I can do one less line of code. I can just take this, and instead of we can just set that at the beginning. I would say set it on game start, but just in case anything happens at any point that resets the GPU settings, we may want it to be reinitialized later. Okay, that's great. So the last issue that we're going to want to deal with is going to be the way that before anything starts, the beam is drawn like off towards the origin of the room, because like I said, when it's initialized, the shader uniforms are zeroed out. We can only draw the beam, and I guess this is the easiest solution. We can only draw the beam if there actually is a target. So if there's no target, it just won't draw the beam to begin with. Which is, again, extremely, maybe don't try this in your science homework, but for gameplay purposes, it'll work. Alright. Okay, so when there's a target, there's a visual indication. When there's not a target, it's not going to be there. Perfect. Magnifying glass beam only draws when there's a target. So just because this is kind of bothering me, but just because this is kind of bothering me, I do want to deal with the transparency issue. I hate transparency in 3D, so do a lot of other people. Transparency in 3D sucks. The short version of how to deal with it, and the fact that like semi-transparent objects will like occlude things behind them if they're drawn first, is to just draw anything that can be semi-transparent after everything else, after all the opaque objects, and just let the depth buffer deal with it. The depth buffer is actually what causes the problem in the first place, but that is neither here nor there. Let me see, where are the variables initialized? So, up here, all UI elements, sure, this is almost like UI, except it's actually not. Semi-transparent stuff is going to equal dslist create. I am going to dslist clear this at the end at the beginning of every draw, every render. Dslist clear. We're going to clear that. If I was feeling like doing things the correct way, I would say self dot whatever, but it's not a big deal, honestly. And then this is going to be a list of structs. Let's see. Do I have a code file of just miscellaneous stuff? I think I do. gameplay help. Let me just make another code file here called drawing. And here we could have a struct that just represents here we just have a simple struct with two members, which just represents a transform for whatever you want to draw in 3D space with transparency and the vertex buffer. So here, instead of drawing this directly, we can say ds list add game dot semi-transparent stuff, new transparent render object, and we can give it these two things that it asks for. We can give it the matrix, which is just going to be this matrix, which we are setting to matrix set transform, and the vertex buffer, which is going to be this. I realize that we also do need a couple other pieces of information, such as the shader that we're using. Which can just be passed as another parameter to the constructor. Shader is going to equal shader, and any uniforms that it might want. Shader uniforms. Okay. So, wow, running out of space here. I really should like break this up over multiple lines. Maybe like this. So we can give it the shader, which is going to be shd underscore magnifying glass beam. And the shader uniforms, I can just make that another struct. I won't feel bad about making that another struct without a constructor. Can be the name of the uniform. So target position. And the variables can be an array of target fo.xyz. So that's just going to be an array of floats. Okay, so we are taking all the information that we're going to need to draw this later, and sticking it in one of these things, in one of these like temporary objects. At the end, let's see, is this render? We can collapse that, collapse that. At the end, what was it? Semi-transparent stuff. At the end, we can loop over the semi-transparent stuff list and just do the appropriate actions with it. If I were to copy and paste this here, we would be saying shader set. If I can look at that on the other window. Shader set thing to draw dot shader. The uniforms that we're going to be setting might be shader get uniform, target position, thing to draw dot shader uniforms dot name. That's the second argument thing to draw.shader. Okay, like this. So we're gonna set the uniform. We could put this in array in case future like I don't want to use the word deferred, since that's referring to a specific kind of drawing stuff later. But in case we want to have some of these things to draw later that can take multiple shader uniforms, we need to set the matrix. Matrix set matrix world thing to draw dot matrix, and lastly we need the vertex buffer that we're going to draw a thing to draw dot vbuff, and this should allow us to just draw it later without any complaints about transparency. This is just doing the exact same thing, just not in the render method of the tower. The tricky part is making sure that everything has the same information that it should. You can come on out. Ah, yes, that's exactly what I want. Yes. I need to say, in addition to shader reset at the bottom, matrix set, matrix world, matrix build identity. Okay, that's an awkward thing to forget. Is that automatically reset in in the other drawing things? Where am I resetting it elsewhere? I feel like alright, whatever, who cares? Okay. So it's working except for the part where it's working except for the part where it's not actually doing this with target position. Oh, you know what? This is going to need to be... I didn't actually put anything in this uniform function. One, it needs to be an array, because this thing is preserved to the struct in an array. Dot elements is what it is, and yeah, it was just passing in a bunch of zeros by default, or it wasn't passing in anything, and they were just staying 0, I should say. All right. Shader set uniform float versus shader set uniform float array. Using the array version is generally quite helpful. There we go. So transparency works. It's all positioned correctly. The lack of semi-transparency in the magnifying glass itself kind of bothers me. Do I want to deal with that? I do. I've been recording for an hour, 5 minutes. That's going to get cut down, but what would be the fastest way to deal with that? Okay, so I've separated the glass part of the magnifying glass from the main tower model, and I've separated it into its own model file. So we'll just give it the exact same treatment as before, as we are with the beam, I should say. So first, we need to load this in as a miscellaneous thing. Magnifying glass beam, magnifying glass, and then we can also ds list add once again another transparent render object, and that can be just glass. It is not going to take any uniforms, so it doesn't need this struct. I can just make this undefined. The shader really can just be a pass-through shader. So I can just say, like, shader pass-through or something, and it can do all the normal things, like be cleaned up a little bit. But we're not going to give it any special code. This is just going to be the code that runs when, like, nothing else happens. Object space position. Okay, and then the shader that we're going to give it is going to be shader underscore pass-through. The uniforms is going to be undefined. The uniforms are going to be undefined. And now I just need to actually check at the bottom to make sure that I'm not trying to do anything with, like, a null object, a null reference. Because that would be a bit of a downer. And that the game would crash. No breakpoints there, please. If this is not equal to undefined, like that, and then we can just continue. So this should cause the middle glass and the magnifying glass to be drawn. And after this, I don't have anything that I want to do here. We are done with towers. This is like the last tower that I want to implement. So you are indeed there on both sides, which is good. All right, that visually looks correct. It's like you're not really there when the beam is active, but that's okay because you can't really see it anyway when the beam is in focus. Let's see, that is all I want to do for the magnifying glass. That is the last tower I want to make. In the next part, we are going to be balancing enemies, I think. I'm going to spend some time balancing enemies, probably 2 videos worth of that. And then, if I can look on my planning board. Let me look at my planning board. I didn't write this down. I should have. Or I should have at least looked at it before I started recording today. Am I doing optimization next? It's getting close to when I would do 3D optimization. Alright, we lost the game. Okay, so after this, I've written down game design, designing enemies, enemy balance. Environmental gameplay effects. I was initially going to have something like, I don't know, like a beacon object or something that powers up your towers or that powers up the foes that makes them move faster or something like that. But I don't know if I'm going to do that. I think I want to keep it simpler than that. That was just an idea I was kicking around earlier. Audio stuff. I guess I should start doing audio stuff now whenever like most of the gameplay is ironed out. I do need to deal with tower upgrading. I'm not exactly sure when I'm going to do that. It'll probably be after the enemy stuff. There's also like 3D particle effects that I want to do. And some other stuff. So that's what's coming up. In the meantime, let's see. In the meantime, I'm going to stop. If you want the code for this project, look for the GitHub repository in the video description. Look for the 0.29 release. I know I've missed a bunch of weeks, so we're actually longer than 29 weeks into this, but look for the 0.29 release. Let's see, create tag. Can I just do this straight from GitHub desktop? 0.29. Yeah. Alright, fabulous. I have a Patreon, so if you want to contribute towards these videos being made, there'll be links to that in all the usual places as well. Otherwise, I try to post a couple of game dev videos a week, one of these and one tutorial. Until next time, I hope you all found that interesting, and I will see you all later. Special thanks to David Key, Edward Holt, Emily Koyo, Posho, and Zenith for supporting these videos. If you want your name in the credits or to hear yourself shouted out at the end, head on over to the Patreon page in the video description to join the fun.